Uh, Hi, today we'll look at this Leetcode medium problem, 79 word search. Given an M and grid of a characters board, and a string word, return true if word exists in the grid. A word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell uh, may not be used more than once. Uh, so in this example, we are looking for this word A, B, C, C, D, E, D, and we're able to find it this way. And this one is A, B, C, B. So A, B, C, but there's no another B there, and we can't use it again. Uh, so basically, the idea for this one is to use a depth first search algorithm to Uh, basically, so if we take this example here and paste it here, so the idea is basically start here somewhere on the uh, start at the beginning from the loop and go through each of them one by one, and once you're through uh, like in a depth first search manner, and since we can't uh, take a cell twice. We can what we can do is temporarily change the value to in this case we'll change it to a hash symbol or something like that, and then basically go by it. Let's just start off. Let's just see if nothing works, we return false. Then we need a depth first search method that will return a bool, and it will take in the row, in the column, and we need an index basically saying, which word are we on. So if we have this word here, so we want to know, are we on this character, this character, this character, this character. So we'll have an index variable here, and then we have to add two conditions for exiting the uh, recursive method. First one, you could say, if you found the word, if the index is equal to the length of the word, then we say return true. And the other one, basically, we can say uh, let's just define an int row being board dot length. Let's say int call will be board dot length. So we say if row is less than 0 or call is less than 0 or row is greater than equal to the uh, we can basically have, maybe I should call this rows and columns rather than, because we have the same variable here. So that's going to be rows, and we'll call this one call is greater than calls, and then we need basically, like for this example, if we have it here, uh, we have this index variable, and we need to know where are we in the index. So we have this uh, we have this moving index variable that will check, will compare it to the words, and if the basically we say uh, if uh, if the variable is not equal to the current variable in the word. So we'll say row and call is not equal to word uh, index, then we just return false. So this one will make sure these things will make sure we're in bounds, and this one will make sure, okay, if we're here ABC and we see an E over here, but we say ABC, we're looking for another C, so we would just return false on this one. And then we have like the the calls here, uh, index plus one, and we need to uh, four of them, and basically uh, we need to have a variable that says found is equal to this. Then we say basically, we can say -1 and +1, and we say -1 and +1, uh, and just and then we could return found. Uh, Now, so this would take care of that, but then we have the situation where let's say we need to reset the value somehow, because we can go from here from A to B to F and then come back to A. Like in this example, we can come back to B and C and go back to B, and that's not a valid because we have used it. So what we need to do is basically have a temp variable, and we'll get the value in temp there, and then what we do once we've added it, we set it to a random character, and once we are through with that, we can set that back to temp. So this would be a depth first search method, and then to start off, then we just have to kind of brute force it with the I is equal to 0, I less than rows I plus plus, and so for int j is equal to 0, j less than calls j plus plus, and then we'll just say if dfs I j and then 0, and if we're able to find the word, we just say return true. So we'll start off. We'll come here, go through each of them, and like in this example, we find an S. We call our uh, so basically we come in and it'll call it for DFS for this. It'll come in here. The length is not going to match. It'll say, okay, this one will say, oh, we're looking for an S. This is not an S. This is not an S. This is not an S. This is an S. It'll come in, and then it'll recursively call. It'll be 1, and the next one would be, it'll check these 3, and none of them are E, so it'll come back here and check in for an S again, and E and E. So let's see. Let's just test this out and see if we have any errors. So there should be a semicolon here. Character length. Okay, I mistyped. Length there. Let's see. This one looks fine. Okay, bool operator. What is the problem here? Operating apply to bool and int. So row those. Oh, okay. So this one is not correct. This should be greater than equal to. Okay. So, uh, okay, so it's saying time limit exceeded. Let me just check if I'm doing something wrong. Yeah, that doesn't make any sense. Why would the time limit exceed for that one? That's the smallest one. Uh, oh, that's the third one. Okay. Okay, so let's just move this down the line. Let's just try this again. Uh, okay, we're able to clear the test. Uh, and we're able to solve it. So, uh, yeah, a simple DFS function with two checks to exit the recursive loop and brute forcing every cell and setting the values and resetting it and checking if the item is found.